Hey everybody, welcome back to the HVAC ADHD podcast. I'm your host, Jeremy Begley. Today's episode is one I've been itching to record. We've got our inaugural sponsor and dehumidification powerhouse joining us, Nikki Krueger from Santa Fe Dehumidifiers. Nikki is the Director of Marketing and Business Development, and honestly, she knows more about keeping homes dry and comfortable than just about anyone I've ever met. We're digging into why so many high-performance homes, quote-unquote, still struggle with high humidity, what's really going on inside your ventilation system, and how Santa Fe's ventilating dehumidifiers solve problems that standard exhaust or supply ventilation just can't, or even balanced for that matter. If you've ever wondered why your new energy-efficient home still feels sticky in the summer, or you've battled that persistent musty smell that just won't quit, this one's for you. Thanks to our sponsors, No-So Labs and Santa Fe Dehumidifiers for making this conversation possible. Let's jump in. Hey everybody, welcome back to the HVAC ADHD podcast. I'm here with our inaugural sponsor, Nikki Krueger of Santa Fe Dehumidification, and I'll let her tell you your title because I just forgot it.
Director of Marketing and Business Development.
Director of Marketing and Business Development. Yep. To me, Nikki is just the dehumidifier guru. She knows everything there is to know about the dehumidification space, and that's how we met. So I'll just briefly take you through my time with Nikki. I just started HVAC Design Partners, and we were in the Lead for Homes program. We were doing a lot of design work. I was partnered with Paul Yankee from Green Building Consulting. Green Building Consulting was the green verifiers on a lot of the Lead for Homes projects in greater Cincinnati area. We were having tons of these brand new Lead for Homes buildings. We're using exhaust ventilation because Lead allows it, Energy Star allows it, everybody allows it. This exhaust only ventilation, which is really just ventilation by adding infiltration is really all it's doing. It's not true ventilation, but including ASHRAE, allow it as a pathway to satisfy the ASHRAE 62.2 requirement. So it's the cheapest, easiest thing to go to. These are brand new buildings built to Energy Star standards. So we're talking 1,200 square foot per ton or better on some of them. So very tight, very efficient buildings, and they were wet in the summer. Every single summer wet. These people were complaining left and right. I bought these brand new homes. We would go out there. Some of it would be true infiltration issues where you're just having infiltration coming into the building and it's hitting the ductwork and it's meeting dew point. But tons of it was just high relative humidity throughout the house, just wet everywhere. And so I had met Nikki once or twice, and I had been aware of Santa Fe, but I didn't know anything about ventilating dehumidifiers. I didn't really understand the concept. I wasn't a basis of design for me at all. Went to the ResNet conference, sat in a packed room. Literally, people were sitting outside. You remember that session? The people were sitting out.
Yeah. Was that in New Orleans?
Yeah, then the New Orleans.
Yeah, it was New Orleans. Yeah,
and it was just packed out the wall, like the biggest session. And I went there because it was about humidity and dehumidifiers. And then Nikki starts talking about ventilating dehumidifiers, and in particular how the Santa Fe ventilating dehumidifier works, where most of the ventilating dehumidifiers like April Air and some other brands that we had seen at that time, they would dehumidify the incoming air, but they weren't doing anything to maintain the relative humidity of the set point in the home. So that's where what she was saying about Santa Fe's ventilating dehumidifier stood out, is they actually brought the air in and they didn't really care about the humidity rate of the air coming in because we were always going to maintain a relative humidity set point in the home itself. And that right there stopped me in my tracks. I was like, wait, this is the solution that I've been looking for all these crazy homes. And so Paul and I met with Nikki and we got to understand. We actually had her do a webinar for our team at the time. And then we got to understand the dehumidifiers and what they could do a little bit better, and started specifying them and pushing them to the local HVAC contractors in the Green Building Program. Lead for Homes, they have a little bit of incentive inside that. If you're building in that program, they give a point out for whole home dehumidification, and they have another very interesting point for control, dehumidification control on your ventilating on the air that you're bringing into the house. So if you had some kind of controlled dehumidification strategy for the air being brought into the house, you got a point for that too. So with the ventilating dehumidifier, we were getting as many points as an ERV would. And so it was a win-win-win-win for us in the standard. We were still able to provide good supply air ventilation. And I like the thing that Nikki said in the in that session too was, hey, the worst you're doing is pushing dehumidified conditioned air back out instead of bringing raw, undehumidified air through the worst places, the cracks and crevices of the building and stuff. So that was another very attractive reason to use that strategy versus a bath fan strategy. So that's how I got to meet Nikki, and she's the expert. So tell us about it.
Definitely, we're not alone.
Yeah.
And still, I mean, in that thinking, right? Like,
Right.
I just had a call this week with a builder and a rater in Maryland, out on the shore, and they're using exhaust ventilation in all these high-end homes out on the ocean.
Oh my goodness.
But in Maryland, and it's just a matter of you have to ventilate. It doesn't tell you what strategies are the best based on your climate zone. And that's the challenging part, is we really need to think about what is the best way to ventilate based on where I'm located and my outdoor conditions during the spring, summer, and fall.
So are there climate zones where you'd say don't use supply ventilation at all, or?
Not really anymore.
Yeah.
Not really anymore. I know it used to be, in an older home, maybe up north in the Midwest, you can get away from it. But to be honest with you, dew points are getting so high and lasting so much longer, even in the northern climates, that there really isn't going to be a penalty with using supply ventilation anymore. So
yeah, and I think one big piece of this puzzle is your guys' smart air damper, which we have been using from it's rebranded from another and improved from when you guys bought Brone. Brone had it first, and then you guys put your stamp on it and programmed it to talk directly to the Santa Fe equipment. That is a big game changer, because previous to that, we were just using open and closed dampers that actuated based on airflow or something like that. But the smart dampers can actually be set to fail shut when the weather outside is either too cold or too humid or too stupid, is what I like to call it, to be bringing in outside air. Either way it goes, it's not a real smart thing to do when the air gets in those extreme temperatures, and any system, whether it's dehumidified or not, is going to have a hard time overcoming that stuff and in the case of the cold air, bringing it back up to temperature. So now we can lock things out. And so that makes it a lot better to control the strategy, the dehumidification strategy, when you're bringing in fresh air along with it.
That's no matter what for the ventilation. I think this is, we can definitely talk about the dehumidification, but the ventilation one is very confusing to people.
Yep.
Because like you said, people assume a ventilating dehumidifier is automatically going to dehumidify all the incoming air before it is delivered to the living space.
Yep.
And that's not the case.
Yep.
When we're ventilating, basically what we're doing is running that power damper, or if you want to run continuous, but the power damper is being run by a timer set, and it's going to activate the fan. So it's not activating the compressor on the dehumidifier, it's just activating the fan in the dehumidifier to bring in that outdoor air for, 20 minutes every hour or whatever you have set up. And when it brings in that outdoor air, it is also drawing air through the return of the dehumidifier, tempering the outdoor air with the return air of the dehumidifier in the box, and then distributing it through the house. So if you're bringing in 90-degree air and it's 70, ideally 75 in the house, probably more like 70, it's going to temper that 6-inch, or now we have 8-inch air, ventilation air, with whatever the return side is, 8 to 10 inch on the return, in the box. So you're always tempering it with more air coming from in the house than what's usually being drawn in through the ventilation.
So that's super interesting. What you just described to me as a poor man's version of an ERV. So
supply.
So that I mean, there is some recovery there that I didn't even think about in those terms before until you started saying that. But yeah, we are, and that's there's some energy guys that do their big gripe is there's no recovery with the, well, actually what you just described to me is some form of recovery that we're just not measuring yet,
It's tempering. We call it tempering.
Yeah, tempering, but it is recovery to an extent for sure.
And then in delivering it. So in our manuals, we give a summertime condition and a wintertime condition of just the ventilation and what that looks like inside the dehumidifier, coming out with that ventilation. Yep. But it is either people think that we are, tempering with dehumidifying automatically, which we're not, because the reality is that it costs money to dehumidify really a small amount of outdoor air.
Right.
And then as a byproduct of dehumidification is we are creating heat. So for every pint of water removal, you create about 1,054 BTUs of heat. So having to cool that air can be very energy intensive as well. Yep. And if we brought in, that outdoor air and was constantly, dehumidifying it, you could be, I'm in the mid-Atlantic, our dew points are consistently for months above 70 degrees.
Right.
So that is a lot of energy being used. So what we really care about is the RH in the living space, because if it's 90 degrees outside for extended periods, your air conditioner, hopefully sized right, is running for a long period of time, that putting that outdoor air in isn't going to matter. The air conditioner is going to be able to handle that amount of moisture from the ventilation when it's running at peak loads. What we care about is when the AC shuts off and the RH is still too high. That's when the dehumidifier should be coming on and running.
Yeah, and that's when people's wives get happy, because that's like I had an HVAC contractor tell me
that's my good hair days.
Yeah, exactly. I had an HVAC contractor tell me, "You've beat on me so much about putting these in. I wanted to put one in my own home before we actually did it out in the wild or whatever." And he goes, and my wife loves you for it. He's like, she's waking up in the morning with a whole different, day. She swears the house feels totally different. She can't believe me being the HVAC guy. I had never put one of these in our house before. So that is definitely where you're going to notice it. Like you said, the air conditioner is doing all the work on the worst days of the year. So that's when you should not be needing it as much. But on those days when you wouldn't have air conditioning in the first place, that's when you're really going to feel the difference of the dehumidification.
Well, and it's, hopefully when we're running at peak load, it's controlling it, but we can design a system perfect and we can install it perfect, but how people run their house,
correct,
you'll never be able to control.
Yeah.
So, that thermostat is their comfort control center. So, getting uncomfortable, all I know is up and down.
Mm-hmm. And you've seen some of the bad stuff that happens with that nonsense. Those affordable housing multifamily units, you had done a big case, your guys, you and your team did a big case study. We had 4 or 5 of them that we were out doing. It's the same problem over and over again. The tenants are in there cranking the thermostat down, trying to be comfortable, not realizing that why they're not comfortable has nothing to do with being cold. It's because the humidity in there. And then all of a sudden, every surface in there is cold enough for dew point, and you got water everywhere. I mean, it happens over and over again.
They get up and they crank it down, and before you know it, we've got a lot of microbial growth, and we've had projects where they have to move them out, they have to remediate not only the interior unit, but the ductwork and the system, and by what really ends up happening is then you've got legal liabilities and you've got reputational issues at that point. So we work with so many developers now, and property managers that it's one of those that they realize the investment up front for like the in wall or that 70 pint, bringing in the ventilation air and meeting their requirements is just way easier to do it from the get-go than waiting until you have a problem.
Oh, yeah. We have projects where they're trying to figure out and go back and retrofit these things in, and that's never fun for anybody. They're like, well, the closet space's only this big, and we need to fit this box in there this big. And they're like, well, what about the walls? And they don't want to cut those open for the, the recirc ones.
The in-wall. Yeah. And that surface mount for that in-wall unit has, saved my butt on a lot of projects because it is like in especially those studios are the number one that have moisture issues because the systems are just too big.
Always
Too big.
I'm in the process of writing a whole blog article. Probably by the time this airs, this is going to air a little later in the year. It will be out, but I've taken all of the multifamily designs that we've done. I've been dumping them into ChatGPT, like every single one. And we have hundreds and hundreds and hundreds of multifamily units that we design. And I'm going to have it do an average of the loads versus ones, and I'm dumping all the ones I can find from projects that I'm on and stuff like that we haven't designed to show the difference because we got everything's 2 tons or 1.5 ton, but most of the time you're seeing 2 tons, 2 bedroom, like you said, studios still sticking with the 2 tons. If somebody really was thinking they're going to do 1.5 tons, but these are things, these units are like 5,000 BTUs cooling, 9,000 BTUs cooling. Like if you're really doing the real low calculation, then you got 24,000, 18,000 BTU single stage. So that thing's never dehumidifying, not once in the history of it being there. I'm on some right now where I walk in, I'm doing the Energy Star verification side of things, and I'll turn on one of my little probes and just set it down when I walk in there, and the thermostat will be reading 71. By the time I get my equipment set up and out, that thing's accumulated to the room, and I look over and it's at a minimum 69% humidity in most of them, and the thermostat saying 71. Some of them will be up like 81% relative humidity, just depending on whether the breezeways are open or shut. Some of them have enclosed breezeways, some of them are open breezeways. So open breezeways are always terrible. Enclosed breezeways, you can at least get it down to the 60% range, but by the time I walk out of there, there's water on all the grills every single time. Like there is no doubt. And these are brand new units. Nobody's even living in them yet. So you can imagine what's going to happen.
Yep.
One of my favorite pictures you ever took is of the lady with the drying rack in the unit that you guys have in your slide.
That was a great.
If you want to talk about tenant behavior, there it is right there.
That's what it was. Yeah, she was so proud of her QVC drying racks that every week when she did her laundry, that apartment was probably around 600 square feet.
Yeah.
It was small. Yeah. And when the supply turned on and you were standing in the living room and it turned on in the bulkhead, the bulkhead and came out, I stood there and my hair was like blowing back. It came on and came off and shut off.
Yeah, and that's one thing that I hate about all these affordable housing they don't want to put a lot of ductwork because they don't want to spend the money on them. So they have one giant grill in the living room that's just like blowing the most air possible down into the space, dude. It is insane. I cannot stand their design the way they do that stuff.
Yeah. And this one was, to be fair, this was like a 1950s retrofit.
But to be not fair, they're not much better these days. Like that is still the strategy that they're using. Blow as much air as possible.
Yep. And now with new, when you got new construction, you've got probably, a humid climate. You got to think about when it was closed in. Was it spring and raining? We've had a lot of those, especially this year. The raining, it's been crazy with rain. And then, you got construction drying going on. Which
correct.
It's going to take a while. So then
underrated moisture problem right there. Yeah. Like people do not understand that at all. Like something like when I say that, a light bulb goes off in people's head, but that is the least talked about part of this problem. But like you're saying, buildings dry for 3 years at a minimum after they're constructed. It's still putting water into the building, water into the building, water into the building. So like, where's all that water going? Well, if you don't have a solution to get it out of there, it's going right back into the building materials and people's lungs and everything else.
Yeah, and then you add people in because they're going to move people in as soon as possible, right? They move them in, and then people are generating.
Yep.
And then we've got our ventilation going, and probably short cycling potentially. Some of the biggest challenges, types of properties are senior housing.
Yeah. Yep.
Because the older we get, the colder we are. Typically blood thinners, that sort of thing. So, they want to crank, I think we've got one of those case studies on our website too. They want to crank that thermostat up to 78, 80 degrees. And with little runtime, you're not removing moisture.
Yeah. And that could be a right-sized piece of equipment and it still wouldn't be running because they don't want it to run. Yeah.
So that's it. People have the control of the thermostat. I remember being at a property in Virginia Beach, and they were having microbial growth, and we were there, and the maintenance manager was telling her, you've got to keep your thermostat at 74. And it was August, and it was so humid and hot outside. And she grabbed her cardigan and said, I should not have to pay to run my air conditioning to prevent mold in my apartment.
I mean, she's not wrong. She needs to be, the one thing I'd say this, I teach a little conservation and cleanup home energy class for the college sometimes. And I tell the kids all the time, like, in America, being king of your castle matters. Like, Americans demand comfort more than anybody else in the whole entire world. That's why they're using, the HVAC and system is always the biggest bill in the house, like, period. Yep. That's what people are willing to pay for is comfort, and they're okay with that. And so, like, to that lady's point, should she have to be uncomfortable in her home to keep her building safe? No, she should not. Like, there's no reason for that.
And she was concerned about the energy, that it costs. Now, It's still going to cost you some energy to run a dehumidifier, but that in-wall dehumidifier is 2 amps.
Yeah.
So, but it is true. I mean, we call it the San Diego effect. Everybody wants 75, 45, 50% RH in where they're living all the time. It used to be, we were like, oh, it's really hot out. We're going to go and sit on our front porch in the evenings, when it was cooling off.
Yeah.
Or, that people accepted that you might get some microbial growth on your clothes or on your shoes. But none of that is acceptable anymore.
No.
We want to be comfortable instantly as soon as we touch a button, whether it's an app on our phone or whatever it is. And, there should not be any microbial growth, in our homes. I mean, we now have all the systems that we need in order to provide indoor air quality through ventilation, to regulate the humidity to that 75-50 manual J design all the time, and to keep the temperature the way that we want it. And we have the systems. And we can go crazy with costs, or we can keep the cost down. We have options, but there is no reason that we should have to have that anymore. We have everything that we need. We just need to plan for it. And that's the challenging part. Like you said, where do we put it, especially after the fact?
Yeah.
That is where I get the calls.
Oh, yeah.
Come find a place. And I'm like, what do you want me to do?
People don't believe till they feel the pain. I mean, that's what everything, like, you got to have a little bit of pain to make people move. Like, even these HVAC contractors with the load calculations and stuff like that, like, they don't care about a lot of them. I shouldn't say all of them. There's a ton of them that do, but there is a large majority that do not care about the load until it caused them a problem, like until it's a warranty issue. And the manufacturer's like, well, where's your load calculation? We're not paying the warranty until we see, that the system was designed and sized right. And then then they're like, oh man, maybe we should be doing that. But until they feel that pain, there's not a big motivation to do most things. That's most humans. Like, you got to really get pushed in the back to change a little bit.
Well, I mean, that's our world, right? Yeah. For dehumidifiers, nobody wants to do it until they have to.
Exactly.
I mean, we thankfully are working with a lot of great builders, but it's, those are the builders that knew from the get-go, and they had customers that would pay for it. Now with more of the production builders, they've learned a lesson. It's, I get the call, I've got a problem, Can you come in? Once you help them solve the problem, then they get it. But they got to feel the pain first. And then, the challenging part, like we said, is, the retro, trying to figure out where to put it. And sometimes we've got to get really creative.
Yeah, you might have to build a space out to house it. I've seen people have to do all kinds of creative stuff, and venting it sometimes you gotta, you can't always do the best practice way that you want to pull return from the house. You might you might have to figure that out a little bit. There's a lot of nuances to doing it on the back end versus being able to plan it out.
Yep.
But the thing is we need to push, it needs to be on people's minds, the engineers and the designers and stuff like that. It needs to be a basis of design a lot more than it is. I just wrote a blog article that got a ton of press that I didn't even expect it to, on decoupled latent. The time is now for a decoupled latent strategy. You gotta, I think that, that extra box is now a part of the equation. There's no getting around it.
Well, and I look, every week I look at design plans. Mm-hmm. I always ask for the manual J. The manual J, I think, is conservative on latent loads quite a bit. And so trying to help the contractor understand that, that latent load is only going to be controlled when that system runs. So yes, you absolutely need to right size it. But you need to understand that, I've been at, Ultra Air. I love that shirt. Wish I still had one. So if yours disappears,
I wore that for you.
If that disappears someday,
the first shirt
then
you
I'm wearing it. But it's understanding that, you should absolutely size the system for those latent loads, but that's peak load sizing you're doing.
That's the thing people have to realize. That's peak. There's other days that are just as bad, and the problem is, to your point in Manual J, that size to peak load sensible is what we're sizing off of. Then you have your peak latent that nobody's really looking at, and that's the thing. You need to look at peak latent, and also where in the part load days of the year that latent is still full peak latent, because there's part load sensible all over the place where you have full latent load, and that's really what people miss, and is becoming more and more important.
Very important. And I think we are seeing the industry push equipment manufacturers more and more for partial load data, like the performance data. We need that. We need to understand what I can expect, especially from a dehumidification point at part load conditions.
And especially with these inverters. I just had Tim on earlier, and we were talking about inverters and stuff like that. That's one of the conversations we got into, is dude, there's no data out here on these inverters for what they're doing at part load, and it can't be much because a lot of them aren't doing too much at peak conditions, So when we get down to part load, we know that it's not wringing out much water at all, whether it's getting the quote unquote runtime or not. When it modulates down to that load down to close to the 25% of your full load, you're all, your latent load then is reduced proportionally by that much, or your latent capacity is reduced proportionally by that much as well. And it's probably next to nothing. So
these are the conversations like Brian Orr, I've been on there. And this is where we always go, is because this is the message that people need to understand, because I hear it all the time. I've got variable speed equipment and, variable refrigerator, and you really need to understand what happens the closer you get to the temperature you're trying to get to, and how that's going to run, and the performance for the latent capabilities it's going to have at that point. So I just was approached a couple weeks ago about speaking at the Heat Pump Summit. Mm-hmm. So I'm very, very excited about that, because I think they realize that is a crucial component of the education process. So I'm excited about that summit.
Yeah, now that did you so the one last year was in Colorado, and I was out there for that. It was pretty cool. So that guy, Brent Davison, the guy that pulled that together, his story is so cool. He knew nothing about heat pumps, nothing about anything. He's like, hey, he's just a homeowner that got a heat pump installed, and he started getting interested in it. So he just dove into the world, and now he created this event and got a bunch of people to come to it, and now it's a thing. So I think it's going to be a very well attended event. And it's the right place for any kind of dehumidification talk, because if you're putting heat pumps in today's world in cold climates, you're going to be using cold climate heat pumps, and you're going to be worried if you're anywhere in the Midwest, Mid-Atlantic, any of that stuff, like you have just as big a humidity problem as Florida does, just for not as long, So like they need to understand both sides of that spectrum, and that's where the dehumidification really comes in, having that auxiliary secondary way to handle that humidity load. Even when that thing's running, like we're talking about, it needs to be when it's not running, those things, you need to even just to supplement what that is doing in itself.
Absolutely.
That's
we're seeing it more and more. That's
one of the changes that they made to the new Manual S since it's been out, is now they're letting the dehumidifiers. I don't think it's written in yet, but one of the red line changes they're trying to make that's out for public comment right now is to let before it said you have to cover 100% of the latent, and then if you have a supplemental dehu, 100% of the latent at peak, and then if you have supplemental dehu during the non-peak loads, you can size a certain way. But now they're realizing, hey, some of these pieces of equipment don't even dehumidify 100% at peak. So we need to, so now they're changing it where you can say you don't have to have 100%. It can be 80% of, if I'm remembering right, I'm saying this off the top of my head, it can be covered. The main system can cover 80% of the latent load, and you can use a dehumidifier, and you can still size towards the heating load a little bit.
I think that's what I recall as well. I recall a former colleague of mine, David Treelevin, was involved with some of the wording with that as well. So I think that's what I recall.
Yeah, so that's important because that's where we're at. Like some of these systems can't even dehumidify on their own, balls out, doing the best they can. They're still not wringing the air out. So there's another reason to have these dehumidifiers in place.
Well, and I think, it's always interesting to me because we talk about ventilation, and ventilation is very important.
Yes.
And it serves one point. It's for health.
Yeah.
Ventilation is for health.
Yes. Yeah. People need to breathe.
That's it.
Simple.
That's it.
Yeah.
A dehumidifier is comfort, health, property protection.
Yeah, building durability. Yep. Yeah.
There's like all these benefits of dedicated dehumidification, but getting people to embrace it but I would say the last probably 5 years, with the building construction practices, even, we say high performance, but even, the most current building code.
Oh yeah, a code built home is a high performance home now. I mean, we say that tongue in cheek because Energy Star used to say you were a high performance home, but most of these homes are built beyond what Energy Star is requiring now just by code. I shouldn't say most because I live in Tennessee. We don't even have building code in some parts of Tennessee. So it's very sporadic what building code is enforcing, but current energy code, buildings built to current energy code are more efficient and higher performing than a lot of Energy Star buildings, except for some of the other things that Energy Star does make you do that may not be, but just by code, from the energy standpoint, they're more efficient than an Energy Star home, for sure, like any modern constructed home.
Exactly. And I think also it's not, people are like, oh, well, who knows what's going to happen with Energy Star? And it's like, but builders also want to differentiate themselves.
Yep.
And one way to do that is building a tight home that you can control the air in. So you can control the comfort. You can control the indoor air quality. They're all very competitive. They want to offer, a lot of them, really good homes in order to differentiate themselves. So it doesn't matter if it's being driven by regulation or not. And people want that. I mean, they're demanding it. And yes, when you go to build a house and you offer them the book of options, they might not pick out, dedicated dehumidification, but I guarantee you after they live in there for a while, you're going to be going back and putting one in. So you might as well just do it up front. Mm-hmm. There was a recent article published by the NHB, and they did a survey with homeowners on the top things that they would expect or that are interested, they'd be interested in a green built home, which, you know, I assume is a high performance home. And I was astounded that on the list, number 12, and I don't know how many, I think there was like 25 items on this list. Number 12 on the list was dedicated dehumidification. It beat ventilation. It beat air filtration. I mean, I've never seen dehumidification called out specifically by homeowners on a list.
I haven't either, but I have been experienced, like, especially in some of the southern states, people are starting to understand that you need it. Like I was dealing with a guy right now that's building a home in Florida, and I was trying to talk to him about ventilating dehumidifiers. He's like, "Are you saying like whole home dehumidification?" I'm like, "Yeah, that's exactly what." He's like, "We already have that in our other house. That's definitely going in here." I'm like, "Okay, well, at least you understand. I don't even have to have the conversation then. We're already there." So that was cool. Yeah. So people are starting to know.
And it's, you know, coming from the company Thermostor that invented whole house dehumidifiers. I mean, whole house ventilating dehumidifiers, but the whole category, whole house dehumidifiers. And seeing, you know, that was the mid 90s, and seeing the growth and the adoption and the interest and even homeowners demanding is pretty cool. You know, the gentleman who invented the, was part of the innovation of these was Ken Gehring.
Yep.
And he's known as Teddy Bear on HVAC Talk Forum, and he's on there still every day. Think he's close to 13,000 posts.
Holy crap.
I know. And people seek him out because he's also the first person to tell you when a dehumidifier isn't going to fix that problem.
That's important to know too, because like, I mean, you've pointed it out many times and we say it all the time, like dehumidification is not going to solve an infiltration problem. It's just not. Like, these are two separate issues. They might help band-aid it for a little bit, but ultimately at some point you have a chance of wetting because, you know, you're going to have dew point in places where you don't want it. So
yeah, I mean, you got to understand and you got to look, and there's a list. You know, I have a list of probably 10 questions when someone says, you know, can you help me size a dehumidifier? And, you know, so I send this back, and it's not just what's the square footage, but you know, all these questions that we need to know. What is the sensible heat ratio of the equipment that's installed? What's the ventilation strategy? How many people are in the home? Where's it located? You know, I mean, there's a lot that we need to understand before we can just say, yes, a dehumidifier is going to fit. You know, do we do a blower door? Do we know our infiltration? Before we can just say, yes, this is the square footage of your house and this is the size. Now, as I always, you know, talk about, our square footage recommendations are very conservative because we would like you to have more dehumidification than you need, not oversize. You know, oversizing a dehumidifier just as bad as oversizing an AC system.
Sure. Yeah.
Will short cycle. Yep. Not good for the equipment. But we want to make sure that we are getting this close to the right size as possible, but we are very conservative in our square footages. And I would say, you know, barring extremes, you know, at least 90 to 95% of the time, that's probably going to be pretty spot on.
For size, yeah. I mean, I tell people that if they can't do the math, I tell them to use the square footage. I mean, I think that from my anecdotal experience using your guys' equipment, I haven't had a problem telling people to use the square footage, you know, for sizing if there's no math involved. Yeah,
I mean, if we have a 1,800 square foot house with 10 people in it and they're home the majority of, I mean, there's you know, there's extremes, of course.
And I've had some weird stuff happen, like, you know, the recirc ones. I'm like, yeah, 1,200 square feet. Cool. Yeah, perfect. And then they're like, this thing's running all the time and it never turns off. And I go there and they're like, well, if you closed the ceiling up and didn't have it exposed to the attic space exposed to the living area, the thing would probably work the way you got to include that open area. You know, people just are goofy sometimes. So,
or, you know, you need to think about having your windows open at the same time that you have the in-wall dehumid. You know, I mean, there's certain things that we got to be, you know, thinking about responsibly when we're on the expectations of the dehumidifier.
Yeah,
right?
and there's got to be a little bit of design, even if it is making sure the square footage is really
sense.
the square footage. Yeah, I mean,
design and common sense will get you a long ways.
And some startup too. Like that's the other thing. Like the thing, it doesn't make a bit of difference if it don't work right. Like I've been over tons of places where you think you're dealing with competent HVAC guys, and then something they haven't installed before, and then instead of taking the time to get on the phone with the manufacturer and you guys and make sure that everything's set up and working right, it's just in and out, and then boom, this dehumidifier is not doing anything, and then you got it not wired right, you got your ventilation not set up right. There's all kinds of different, especially with the ventilation piece. Like there's a lot of nuance when you're dealing with the ventilation piece on these ventilating dehumidifiers.
And I take great pride in our manuals. Yes. We can't cover every
updated
scenario.
Manuals are awesome. There's so much more information in there now than there used to be. I love it, man.
And that's you. That's Tim. That's the HVAC school community. I mean, it is the contractors that have supported us and their feedback, and we take it. Yeah. I want to put as much, because I understand when you're in a 140-degree attic trying to install one of these things, the last thing that you want to have to do is try to call and get a hold of someone in customer service, or leave the job because you don't have everything you need. And so we try to, cautions and warnings, and yes, there's all these different install options, but you need to understand the pros and cons of those and make sure that you have all those components. I tell you what, the number one thing that people forget is that backdraft damper. Mm-hmm. On that supply side, you got to have that backdraft damper. But it's it's in there. It's in every illustration. It's called out, but
people are so crazy. I'll send that. That's the best illustration. Like literally, you can't have a more dummy-proof illustration of how to install a thing. And I'll send it to people, and they still never even look at the thing. Okay, and then they're missing stuff off of there. I'm like, well, it was on the diagram, and it's in the parts list. I don't understand how it didn't make it into the actual install. It blows my mind.
Yep. Yeah,
but it happens a lot. That's why commissioning is so important. We got to the point where we're writing full commissioning plans for people, because if you don't spell it out word for word how you intend it to be installed and operated, people are not going to take the time to install it the way that it's meant to, even if the manufacturer's stuff is there.
And we've got a labor shortage in the trade, and we've got people using different manufacturers of these equipment with different recommended for installs and different features on these units. So it can get very confusing. And that's why, my goal was to make the manuals as clear as possible, as easy accessible as we can, because we want the contractor to be successful and we want the homeowners to be happy. I get called into projects, and I'll go look at the dehumidifier, and the dehumidifier isn't working, and I'll go, and it's typically 95% of the time it's going to be an install.
Oh yeah, I mean,
even 98% of the time.
You get bad compressors and stuff like that, but usually you get bad installs a lot more than you get bad compressors and bad parts and stuff. That's one of the reasons, Goodman, before they got bought by Daikin, they had gotten such a bad reputation, and they had one of the best warranties in the industry, 10-year labor, 10-year parts warranty on their stuff, and they still couldn't get any traction because they sold to anybody, and everybody out there, no training, no nothing, and guys just didn't install it correctly, chucking the truck, setting it down and walking away. So everybody's like, that Goodman sucks. I had guys out there that knew what they were doing and installed nothing but Goodman, and it was fine. And that labor warranty meant everything, But if you got guys that are just setting things down and walking away, it doesn't matter what the equipment is. It's not going to work right.
Yeah. And I think, the other pushback that we often get is, we're going to install another piece of equipment.
Yeah, that's a big pushback, actually.
And I understand that. But to have to maintain something twice a year.
Yep.
And for the benefits that it delivers, when you already have to maintain the HVAC system as well, it's just part of that.
I think they just need to call Florida, because Florida's figuring it out. They're like, yeah, we got to do literally, my brother works for one of the bigger HVAC companies in Melbourne, Florida. And on their new construction side, that's what they put them in spec because they know that they're not going to have a problem in the house if they do. And if they don't, with modern construction, there's, and those are all encapsulated attics and everything else down there.
Yeah.
So like you're going to have some humidity issues if you don't worry about the humidity. That's for sure. So down there, it's becoming common practice, and that's where the whole U.S. needs to do it.
It's a warranty thing, I mean, as soon as they can see a reduction in warranty calls, for sure, for wood flooring,
wood
cabinetry, microbial growth, paint. I've worked with builders that, especially if they're doing crawl spaces, the paint above the trim on the first floor starts bubbling. And so, they'll have a warranty call for that.
Yep.
And so once they realize that it can reduce the warranty calls and liabilities, that's a big selling point as well. And if people are happy in their homes and how comfortable it is, and they tell other people. I mean, that word of mouth is huge.
Yeah, especially for new homes. I mean, it's big time because they can really get especially like a production builder, you can get a bad name really quick. You build a bad swat of homes, people are going to know about it for sure because they're building the same one over and over and over again 20 million times in a row. And when all those are working the same way, you got a problem that makes it on the news a lot of times, like that's just how bad it gets.
That's the most, inexpensive time to install the dehumidifier is during construction. The costs are all over the place depending on where you are in the country of how much an install is going to be.
Yep.
But it is always the least expensive when we're constructing that home. And it'll
for sure. I mean, that's when the dollar is not. It's it's a 1-for-1, dollar for dollar install any other time. When you're building the home, it's in the cost of construction and you don't even fill it. Any other time, it's coming right out of your pocket, and that's when you're going to fill it the most.
Exactly. And at that point, there's a bigger, there's a desperation. I need it now. There's a lot more going on that's going to contribute to that cost as well.
Absolutely. Okay, I'm getting the wrap it up signal here from these guys. So
already? Holy smokes.
Yeah, we blew through 40 minutes. It's good conversation. I love it. So before we go, three things actually. One, thank you very much for taking a chance on us and being a sponsor. We are so grateful that you did that. It helped us get everything moving. So big thank you to that.
Absolutely.
Number two, is there anything you want to say, tell your products, your website, all that stuff? Anybody you want to tell people?
Well, so we have launched, which I know that I saw your text about trying to see if we could get that V155 something. Unfortunately, I couldn't, but so we did launch the new Ultra V155, and the V stands for ventilation. We have now moved to an 8-inch ventilation duct on the 155 and the 205. And that enables us to bring in more outdoor air to match the dehumidification capacity of the dehumidifier for the right size of the house. So I'm sure, as contractors who are measuring ventilation now, what we were seeing in some installs where we've got several turns on that ventilation duct, not pulling it tight, long runs, that we were having trouble bringing in that outdoor air CFM number in order to satisfy whatever requirement or standard we were trying to meet.
ASHRAE, yeah. I think your guys' ventilation journey has been cool. Like when I first started doing, you're like, hey, the ventilating dehu, and then, I'm like, hey, what about this ASHRAE thing?
Yeah.
You're like, not quite there yet, but we're going to get there. And then like the next thing I knew there was advice on how to tweak it in the field, and now boom, you have a new piece of equipment that actually
more ventilation. And again, you don't have to use it if you're using another strategy, but so that those two units both have the new 8-inch duct on them. There's a lot of other cool things about the V155.
The onboard controls, the deployable sensor. Like I love it, dude. There's all kinds of really cool little new toys on those things.
The dedicated port for a P-trap.
Oh yeah.
So, and then what we're going to see is moving forward is the 98 and the 120 are now moving to the same design.
Nice.
So
I can't wait.
And so that V155 is 40% smaller than the old V155.
Wow.
And so that same cabinet size is going to be used for the V100 and the V125. So the 98 is going to 100 pints and the 120 is going to 125 pints.
Awesome. I cannot wait. I'm so happy for all these upgrades.
Yeah, so that will be the middle of September. Those will start running down the line.
Cool. Cannot wait.
Very exciting. Yep. So
one last parting shot here. World goes away and they ask you to leave advice for the rest of the world on the wall. What are you going to write? Industry related.
Oh, boy. I would say embrace whatever situation you are in right now and make the most of it. And friends and family come first.
Hey, I love it. Absolutely.
Yeah.
It's good to have friends in high places.
It's without relationships, whether it's, professional or personal, it doesn't matter. This is what it's about. And I appreciate everything that you are doing. This is incredible. And your passion for the industry. We need more. We need more of this. And especially with the younger trades coming in, this is how they learn.
Yeah. Oh, yeah. 100% nowadays. That's the thing. Like, I think we have a way better chance of affecting the industry now more than we ever did because people are online and they're seeing other people talk and they get interested and stuff like that. Like the online community for our industry, since I've been involved in 2008, 2009 is when I got into the industry. I met Allison and all those guys on Twitter, and that was the thing back then was Twitter, and now it's sort of morphed into, there was a BPI LinkedIn group and now just out on LinkedIn. But as that grew, we've seen the crowd get younger and younger, which is really cool. We have a lot of young people interested in the tech side of it and just high performance HVAC, which is awesome.
The high performance is where it needs to be. And, I find so much value. I learn a lot. Brian's HVAC Facebook group, that group,
amazing.
They have taught me so much. So it's exciting. And again, congratulations on your journey.
Thank you.
Yep.
We'll have to do it again for sure. Thank you so much for coming on and everything you've done. I'll see you later, Nikki. Thank you.
All right. Thank you.
Bye. Hey, everybody. Thanks for stopping by. If you'd like to learn more about the podcast or HVAC 2-Home Performance and any of our services, be sure to check us out on our website at HVAC2homeperformance.com. Also, be sure to subscribe to our YouTube channel at HVAC2HP and find us on Spotify and Apple. While you're at it, leave us a review. The HVAC ADHD podcast is produced and edited by the team at Palm Tree Pod Co. Anthony Palmer is the executive producer. Bo Patton is our technical director. Nolan Gray is our audio engineer, and Caitlin Krings is the head of digital. The content for this episode is created by me. Hooday, go Bengals!